Hey folks, Mark Brown, Azure Cosmos DB TV. Welcome back after a very long hiatus we took after Build last year. Although we did have some shows, we had Tara from our team, I believe, host a couple of shows over the summer, and we had her last week hosting while I was actually the guest on the show. So that was a bit of weird musical chairs for me. Yeah, I haven't done that. I've actually never done that. I did a self-hosted show. Like, I think it was our second or third show. It was me talking about like management and control plane stuff. So I actually hosted and guested. Guested doesn't sound like the right word. But now it's back to normal. So Justine, good to see you. It's been a long time.
Yeah, hi, thanks. I'm glad to be back. Really excited.
I don't know if, well, I know you know, but maybe for others. So I'm in a different location now. Part of the reason why this took so long to get the show back is we ended up leaving California. So after we took a very nice vacation, we were in Asia, and then I got back. Well, at some point before then, we decided, well, let's sell the house and move back to Seattle. So before I left for Asia, we put the house up for sale, and then that sold. And then I got back, and then we had to pack up and move, and that made it very difficult to host a show.
Yeah.
Do basically anything for a long period of time. And then, I'm still trying to kind of get things situated for living and finding a place to do a studio. And so anyway, we're now working and recording out of our new offices on Microsoft's campus. At least that's where I'm sitting right now. And we'll see. We might be a traveling show here for a little bit while we figure out
Yeah.
what we're doing from a studio. But at least for all the guests, hopefully things are the same. And I'm sorry, you and I, even though we were near neighbors down in the Southern California area, never got a chance to get together and go have a beer.
I know.
So I'll have to come and visit you out on the Huntington Pier maybe sometime. Well,
Yeah.
if Ruby's is still out
California
there,
waits.
we'll go out there and have a greasy burger and a Coke or something like that. So you're going to talk to us this week about some, basically just updates on all the awesome new stuff with the .NET SDK. It's been, at least a year maybe since you and I talked, and there's been a ton of new stuff that's been going on. And we're going to talk about that today, aren't we?
Yeah, it's really exciting. So we have a lot of new stuff, and we'll also review some old like best practices and tips and tricks, or maybe not old to everybody, but even things that have been around. Sometimes they don't get a lot of love, or people forget what they're for. So we'll definitely cover how to configure the SDK, some best practices, and then really the star of the show is going to be our news story around observability and monitoring. We recently, actually at Build, announced our OpenTelemetry support, and we've made a lot of improvements since then, and we're going to GA it soon. So we'll talk about everything that's changed. I'll give you some pointers to what might be changing in the near future. Then, of course, we'll have that support story as GA. So really exciting topics for today.
Well, that's awesome. Hey, let's dive right in, I guess. I want to move us off to the side here so we can take a look at what do we got? Is this VS Code here? No, this is like full on Visual Studio you got here.
Yeah, this is full Visual Studio. So I have a really simple application. There's no slides for today, so we'll just walk through everything. Of course, in SDK talk, we're going to be in the code the whole time. So I want to start by talking about, when you get the SDK, there's a lot of client options, and it can be kind of overwhelming, even just the first step before any of your business logic, like how do I set this thing up? So I wanted to really start here with the options. And there's a couple that are really important to highlight. So let me actually make sure my mouse is clicked into the right spot. Here we go. All right, so the first one, many of you may be familiar with this, but this is actually the connection mode. So I'm going to go ahead and set my connection mode, and let's just set this up to direct mode. There's actually two modes for connectivity in the Cosmos DB SDKs. If you're using the .NET SDK and Java SDK, you'll have the option for direct. If you're using our other SDKs like Python, JavaScript, they only support gateway mode. But what is the difference? So the direct mode actually connects, the SDK is connecting directly to your backend partitions. So as a distributed database, your data is distributed across multiple physical machines. And in direct mode, instead of going through the gateway, the SDK is actually reaching directly to those nodes. And each partition has multiple replicas. So this could be creating, potentially a lot of connections.
Yeah, in fact, that can cause SNAT issues. We've seen in the past with customers who are running over, is it Azure Load Balancer, I think, in the past. But we see, I just bring it up because I see customers sometimes are like, what the hell's a SNAT exhaustion? And they get confused by some of these network errors. And we've got good guidance on how you can kind of avoid those types of issues, right?
Yeah, totally. So there's a lot of things that you can do. And even one of them is looking through the diagnostics to see, how many open connections do you have and making sure that you configure it properly for your actual host environment. So when we get to the diagnostics, we'll look at, how you can get better visibility into what's going on under the hood. For applications making many connections to a lot of partitions, it can be difficult to manage everything. So there's definitely some tips and tricks to that. The other alternative, if you're not using direct mode, is gateway mode. And what gateway mode does is it actually routes your request through the Cosmos DB gateway, and the gateway is what's making the calls to the backend partitions. So still talking, of course, to the partitions to get your data, but through that intermediate step, it can see slightly higher latencies, but it has the trade-off of fewer open connections. So there's definitely valid use cases for both. Direct mode is actually the default, so I don't need to set this up here, but I wanted to make sure to highlight it in case you want to change it, or if you just weren't sure what the connection modes even meant to begin with.
Yep.
The next one we should talk about is consistency level. So, oops, not that. Every time I try to type something live, I get too happy with the IntelliSense. All right, let's see. Consistency. This is really proving if I can spell. Consistency level equals consistency.
Why is it auto? There we go.
Yeah.
There you go. Right.
Let's go ahead and set this to session. There's 5 different consistency levels for Cosmos DB. Session is the default, and it's also what's configured on my account. So again, I don't need to set this. The SDK will be able to pick up the consistency set at your account. But say you have multiple different Cosmos clients and you wanted one of them to have session, but another one you don't care about reading your own writes. You just want to read, eventual consistency. So eventual consistency has the lowest latency, and it is beneficial in a lot of ways. But of course, you may see slightly out of order reads and writes. So there's well-defined levels, and we let you choose it at the account level, at the client level, and also at the request level. If there's a specific request that you want to have a different consistency, so you can fine-tune all of that directly through the SDK.
Yeah, this is beneficial, by the way. One great use case I point out to customers is if you've got a workload where you're using strong consistency, so you're basically pushing every write is going to get pushed into every region and every replica immediately, and you're going to pay for that in the writes and the latency for that. But where you also get paid for that is when you read from strong consistent accounts, you're reading from 2 replicas, so every single point read is going to cost you 2 RU versus 1 RU. And if you have clients where you don't care about whether or not you're getting the perfect, clean or perfectly consistent data, and maybe it's something that's doing like a dashboard or providing some kind of, lazy update, like the golf scorecard would be a perfect example, right? Like you don't need perfect consistency. Like if it's eventually gets the latest scores on there, that's fine. You can do that and not have to pay a penalty for the reads if you just set that to like what you were saying, like session or even eventual. And then it could just kind of lazily read the data. And then it, of course, like the name says, it'll eventually be consistent. But you don't need that. You don't need expensive reads. And that's kind of the benefit is if you're going to have very strong consistency because you need it for your workload, if you have clients that don't need that, then use what Justine's showing here. And then those will be more efficient on the reads. So.
Yeah, and the other thing to consider, especially when you have multiple regions, if you're using multi-region write, strong consistency can be really painful. And there are actually limitations just due to physics. We don't even allow you to have multi-region writes on regions that are further than a
strong.
certain number of, strong on like certain distance. So that actually ties in really nicely to the next option that we're going to talk about, which is application region. And this is really important, especially if you have multiple regions configured on your account. You need to tell the SDK, like, where is your region? Where's your application located? So that it knows the closest endpoint to actually reach out to. So I have an account that is configured with multi-region. So I have a region in West US, and I also have a region in East US. Sorry, this is in a VM. It's like very slow, the typing. I'm like typing away and it's going so slowly. But there we go. So my VM is in West US. And so I want to tell my application to actually reach out to my West US endpoint. And what this does is it actually sorts the other regions in proximity to the one that I selected. So if I did have to have a cross-region retry, something like that, maybe just a local transient failure, I can always fall back to my next region, and it sorts all the regions in my account in proximity to wherever I selected. And this is actually important, even if I say my VM was in a different region. My account is in West US, but let's say my VM was in West US 2. I can still set West US 2 here, and the SDK will automatically know all of the regions my account is actually in, and it will sort them in order of proximity to wherever my application is. So it doesn't necessarily need to be the region of your account, but it should be the region that your app is in. And yeah, it really helps with like latency and high availability in multi-region scenarios if there's like transient failures.
Yep, cool.
The other way to set this, say I didn't want to set my application region specifically and have the proximity just automatically decide the order of all my regions, you can also do something called application preferred regions. And what this does is it takes a list of, oops, my keyboard is faster than my loading computer. You'd think it's faster when I use a VM. I thought this would be a perfect improvement. But anyways, so
weird latency, huh?
yeah. So I can give a list of regions here. And regions, let's see. I want to pick West US. And then I also want to pick East US. I'm not going to type the whole thing. You get the picture. So you can add your regions here. If you wanted a different order for some reason, say there's a fallback region that doesn't really have a lot of traffic, and maybe it's a little bit further, but you want to make sure that your RUs get used there instead of your like high throughput region that maybe has more contention. So there's a lot of reasons why you might want to control the proximity, or you might want to control the order outside of just proximity. And another thing to note, you cannot set both of these settings. So if I ran this right now, it would error. It would say, oh, you can't set both application region and application preferred region. So it's sort of one or the other.
Okay.
I'll just leave application region for now. And there's one more client option that I want to discuss, which is bulk mode. So let's go ahead and set allow bulk execution, and let's make that true. So a common conception of bulk execution is that it offers the lowest latency and highest throughput, which is actually a half-truth. So what bulk mode does is under the covers, it's actually sorting all of your requests into groups by partition key. So it will sort, say my container is partitioned by like city, it will sort Seattle all together and then LA all together, and it actually will wait to fill up those batches, and it allows for higher throughput. So bulk mode is associated with throughput. But say I couldn't fill up my bucket for whatever reason, and the way you fill up your bucket is by either 2 megabytes or 100 items, it will actually wait 100 milliseconds before sending that request. So say you have a couple partitions that don't have a lot of data, you could actually be getting that extra latency, like waiting for your bulk to fill up before the request gets sent, and it could see lower latency. Now, if you really do have both high throughput and a lot of requests coming through, then typically this will be the most performant option. But it is a caveat to mention because a lot of people don't actually realize how it works under the hood. And they might think, oh, why did my latency go up? I added bulk. Yeah.
And that's why, right? Because we're trying to saturate the throughput to optimize the usage and also the network, the pipe as well in there,
Yeah.
and sending and packing everything into as small as package as possible over the network is also part of that optimization that happens within there.
Yeah, totally. So I'm going to get rid of this again for my application because I do not have very high throughput and I don't want to add that extra latency buffer. So one more thing to mention for the client before we move on is the way that you create the client. So this is a console app, and of course, I'm just creating one client, and it's pretty straightforward. But say I was using like ASP.NET or something like that, it's really important that you create your client as a singleton. And this is because there's a lot of startup cost. Remember, we talked about direct mode, reaching out to all those partitions. Well, how does it know where the partitions are? How does it know what the regions are? It's getting your region list. Like there's a lot of metadata and initialization cost to creating a client. So if you're not using a singleton and you're constantly creating and disposing of your clients throughout your application lifetime, you're actually adding a lot of overhead and a lot of latency to your requests when you might not be even realizing it.
Yep. Also helpful just to DI these things as well when you're creating your applications and just passing it around versus letting them go out of scope as well within there. So yep, very important. In fact, that's still surprised how often we see that. Like, hey, the performance on this thing sucks, and then you look at their code and you're like, dude, why are you doing that? You're creating, you're newing up a client every single request. That you realize that's a bad idea, right?
Yeah, it's going to be very expensive. And we'll actually look at just a little teaser for the second half of the show, but we'll look at ways that you can identify like how many clients do you actually have? Because maybe you have a very big legacy application. This is just a couple hundred lines, right? It's easy to tell like exactly what's going on. But for some applications, it can be difficult. And so we'll look at ways through OpenTelemetry that you can actually debug this yourself and understand really how many clients you're creating because it might be surprising. Yeah.
Oh, that's cool. All right. I'm looking forward. Now you're teasing me with stuff.
Yeah. Teasing just within the 1 hour show. Yeah. Don't skip.
Yeah.
Please watch the whole thing. Okay. So let's also talk about the database and the container. So I'm actually using my get database and my get container calls here because I know what the database name is. I know what the container name is. I know they're already created. I think a lot of people are tempted to use the create database async or create database like if not exists. Which is also in here. IntelliSense is not working today, of course, but this is an option. What this actually does is it's doing extra metadata calls to Cosmos DB to see, does that database exist? Oh, no, it doesn't. Okay, go create it. So it's doing those extra trips, which just add extra latency. So if you're using this in the hot path, it's really recommended to just use get database, get container, just do the metadata calls. It's not actually calling anything. It's just metadata in the SDK, and then it will make the call when it needs to. So this is another tip.
Does that when you call the get database, get container functions versus the create if not exist, like I think those also, they don't actually get the actual handle. Like they don't actually execute until you actually make your first request. Is that true?
Yeah, exactly. So this isn't calling Cosmos DB at all. It's just metadata in the SDK in our like information of metadata for the SDK. Basically, it's just storing what the database name is so that later when it makes its first request, it can actually go get that. And we can see that too through the tracing in OpenTelemetry.
Right. So that's another thing is you're always, obviously you got the connection, the client itself, but also your first request. That's not just get database or get container, but it's actually touching the data store with some CRUD operation where you're going to get some latency on that very first call, right?
Yeah. There are options to avoid that. Like there's create and initialize methods, which will initialize the connections for you if you want to make sure you do it again, like outside of the hot path, or if you don't want that first call to have high latency, you can do it before the first call. So there are ways around that, but in general, it's recommended not to have those heavy metadata calls, the create if not exists in your hot path.
Yeah. or run benchmarks on it. That's where I've seen
Right.
customers
Yeah.
do it.
Yeah.
They're
You
like,
need the warm up time.
"This
Yeah.
is so slow," and I'm like, dude, come on. This is
Yeah. One request was slow.
let me
Yeah.
help you. Hold on.
Yeah, totally. So the rest of this app is pretty simple. I'm just going to go through, we're going to create a product, we're going to read the product, and then we'll query the products. I'll just kind of walk through the code and then we'll run it. And we'll look at just a couple of things. So for the create product, there's nothing groundbreaking here. This is just our normal create APIs. If you've used the SDK, you've likely used this. One thing that you might not have seen, which I want to highlight, is the stream APIs. So you can see I have my create item async, but say this was a middle tier application where I don't actually want to spend the serialized and deserialized cost of streaming the actual item. And I just had a stream and I just can pass that around instead. So these are really great for low latency and they can have really big improvements. But of course, you don't have the item. So if you do want to use the item, manipulate it in your business logic, the stream APIs don't always make sense. But especially for middle tier pass-through scenarios, you can see big perf improvements here.
Yeah.
All right, so let's get rid of the stream. We do actually want to use these items. And after we create our item, we're just going to print a couple of things. So we're going to look at the diagnostics. We'll get the client elapsed time. So how long did this create operation take? And we'll also print the request charge. After we get our product, we're just going to read our product. So again, simple point read, nothing groundbreaking here. And we're going to print the same couple of metrics. And before I run this, I want to also review what is going to happen with our query. So if we look at our query, you'll notice that there are a couple of request options. Of course, there's request options for the create and the point read too, but there's a couple query ones that I do want to highlight. I've talked about these on the show before, so we're not going to go into super deep detail, but these are three things that you can tune. The max item count will be the number of items that are actually fetched for each round trip. So the default is 1,000. If you set it to -1, the SDK will just fill up whatever it thinks is optimal. The request maximum is 4 megabytes. So we'll just fill up to 4 megabytes or pick some amount of items that's optimal to send back. Max buffered item count is the number of items that are actually buffered client side while the next trip is being fetched. So this is also really helpful for latency. If this number is too low, then you might be doing a lot of extra work or just waiting around for the next batch to come through. And the last one is concurrency. This is really important if you have a cross-partition query with a lot of physical partitions. You want to make sure that the SDK can actually make those requests concurrently instead of sequentially looping through, all of those partitions. It could add a lot of overall time to your query.
Generally, so I've seen people mess with these things quite a bit in tweaking. And in my experience, I find that the more people mess with these things, the less they get out of it, I guess. And I want to get your thoughts on this. Like, I generally tell people just don't even bother touching this stuff unless you are into some deep kind of per request optimization. What are your thoughts, I guess, when thinking about these things?
Yeah, generally I agree. We do try to pick good defaults. We're not just going to put any random number in there. So the defaults are generally good. I will call out -1 allows the SDK to decide what is best based on the conditions of your machine and your application. Yep. So setting it to -1 is not going to be bad. There are a couple things for various of these to consider. So max item count. Obviously, if you have pagination, you can use offset limit, you can use take a certain number, or you can use item count to help you get pages of a predictable size. It is a maximum, so if you're asking for more than 4 megabytes of data, we won't give it to you. But that's one thing that max item count is helpful for. Max buffered item count really affects the memory on your machine. So for some machines that are really memory sensitive, you may want to tweak this just so that the SDK is not loading a bunch of items and then you have no memory left for your application to run. So there are some reasons that you would want to tweak them, but generally I agree, we do set good defaults.
Yep. Yeah. And like you were saying, the key word there is that it's based upon your machine, right? And the performance of your machine. So unlike setting these things, if you let us do it, it can change, right? Like you may be sitting and hosted on a VM instance or a web app instance or some compute instance that's changing due to other parameters or other things that are happening within the app. If you hard code these things, then you may introduce issues elsewhere. So just, I don't know. I just think simple is best. And I see more success with people leave these alone than when they tweak these things, I guess. So it's
Yeah, definitely.
my 2 cents. So.
Okay, so after we have all of our options, we're going to get the query iterator. We're going to iterate through our results. Very important that you actually drain all of the pages of your query. Sometimes it might seem like, oh, I didn't get everything, but that was just page 1. So we're going to iterate through as long as we have more results. And I'm going to point out a couple of things that might be interesting to look at. So we have here just adding our results, of course, that's pretty standard. We have our RU charge. How much did that query actually cost you to run? You can look at the diagnostics and you can get the client elapsed time. So this is the amount of time that it took to actually run the query and get the query back. But we also expose query metrics in our diagnostics. This is actually new. We used to offer them. I mean, they've been in the diagnostics for a long time, but the V3 SDK did not expose them as a strongly typed object until recently. So now you can get a bunch of information without having to parse that diagnostic string, which can be a little bit painful. And we can look at where that time is being spent. So we have the client elapsed time for the whole request, like how much time was it? But in query metrics, we have total time. Total time is the query execution time. So on the server, how much time did it take to actually execute that query? And it breaks it down even further into index lookup time. So if I did indexing properly, there should be some index lookup time here. Ideally, I'm using an index for my queries. We have our query preparation time. This is anything from compiling the query, building the logical, physical query plan, and also query optimization time. So our query engine is constantly getting better. Our goal is that we're a developer-friendly database. We want you to spend as little time thinking about, fine-tuning your query as possible. So there's a lot of things that the query engine does under the hood to actually optimize your query, and that all goes into the query preparation time.
I got a question. Is the diagnostics string now that's strongly typed, is this the same one that has all of the RNTB information, like the partitions and all of that other, like what partitions were touched and the all the other kind of transport layer stuff that's going on there? Like that used to be an insanely complicated, somewhat kind of quasi JSON string, if I remember.
So the diagnostics still is that way. The diagnostics is a string. The diagnostics itself is not strongly typed. And the reason is there may be changes there. We don't have a specific contract that we promise to not change. We're always changing this to see if we need to add something or take something away. We don't want to send too much data, but we want enough data to be able to diagnose issues. So diagnostics itself, unfortunately, still is like a bit of a mess, but we will get into some ways to make that a little bit easier with our new OpenTelemetry integration.
Got it.
But what is strongly typed is the query metrics specifically. So if you wanted to look at all of these things for your query, it's a lot easier to do that. And this is, you probably wouldn't be logging this for like every single query, but especially if you were debugging something or you had a slow query, you want to know what was going on, this is really useful.
Okay. Yeah, I got it. And that's what everybody has told me in the past is, hey, look, that's a lot of that is it's for us internally. And also it can change and does change. And it doesn't make sense to strongly type that just simply because of that. But if you really want to get into it, dump it into a string and run some regex over it and you can pick out what you need kind of, so. Okay, that's cool. At least you got the important stuff in here. Like all these query metrics, obviously, are going to be very, very important in here. So this is great stuff.
And one more thing I want to mention about the query metrics, if you notice, there's two actually things that we're looking at here. So there's a cumulative metrics and there's also a partitioned metrics. And I want to clarify this. So the diagnostics and all of these metrics are within the context of one round trip. So when we say cumulative, it does not mean cumulative across all round trips for this query, but it's cumulative across all of the physical partitions that were actually reached out to. So you may have a single round trip that talks to multiple partitions, and each of them will get their own partition metrics. So all of these things that I've mentioned here are also available for each partition. And this will help you debug things like if you had a cross-partition query, but one partition had like the bulk of the data and it was sort of skewed for some reason and you wanted to debug that. Or if there's one partition that's like slower than others or something like that. So it gives you a lot of insight, both at the cumulative level, so like what's going on with the whole round trip, and then also for each partition.
Yeah. Yep.
And so I'm going to go ahead and run this application. We saw it's very simple. So remember, we're going to create a document, we're going to read a document, and we're going to do a query. This query is by category, which happens to be the partition key for my container. So this is a single partition query. And I just want to point out, so we can see the latency here for our first request is a little bit higher. It's almost a second. Again, that's because we are making those metadata calls. We're actually reaching out, opening the connection to our container. This is the first call. So that's why you see the latency a little bit higher. Our read item was much faster, only cost 1 RU. And when we get to the query metrics, we have our client time here. So this trip took about 1.5 seconds. But you can see the time that was actually spent on the query execution was only half a second. So this gives you some insight into like network time. Obviously, my VM is loading a little bit slow today, so maybe there's something going on with my VM. But it really breaks down like where that time is spent. And we break it down even further when you look at the index time, the query prep, runtime execution. I think there's even a couple other times. I didn't pull everything out of query metrics here, but this really starts to give you more insight into what's going on under the hood. And again, this is really advanced troubleshooting. So we don't expect like every single query for you to look at this, but I just want to show you what the SDK offers if you're looking for more advanced.
No, and some key metrics in there, like index lookup time. Like, did you spend any time on the index at all? Right. You want to see something there because that's going to indicate whether or not you're hitting an index on this stuff.
And another thing for that is looking at the retrieve count versus the output count. So of course, if you have an aggregation or something, you maybe are only outputting one document, and that makes sense for those to be mismatched. But when you're just projecting all of the items that you found from your query, these should be similar, right? You don't want to be looking through more data than you actually output. And that indicates that maybe you're not using the index effectively. And of course, there's some system functions that can't use the index. We have computed properties that help with that. But there are cases where these will be mismatched. But in general, you do want to look at some of these things and just make sure, like, is my indexing policy right?
Something wrong there. If you've got a massive retrieve document count and a very small output, and that's something to look at. So,
Yeah, totally. So one more thing, I'm going to run a slight variation to this query, and we're going to do a cross-partition query just so that you can see how it actually changes what the metrics look like. So I'm going to actually paste this query from here, and we'll just run this one more time. I just want to show you the difference of the query metrics, and we'll also see this has an order by on a field that is not the partition key. And so if you see this first trip, we actually reached out to 5 physical partitions. There's 5 physical partitions in my container, so I'm talking to all 5. And then some of the subsequent trips are just getting more data from each of those. But I need to go to all of my partitions because I have an order by that's cross-partition, right? So the SDK needs to actually do all that work client side after it gets the results back to make sure that even across partitions, we're still sorting all of our data properly. And you can see like on each trip, what partition key we were reaching out to. I think the range ID itself is not as important as understanding like what the spread is, right? So you can see like, oh, I'm talking to all of them, or maybe one of them was missed, or one of them was slow. You can look at the total time, like maybe one of them, partition 0, is constantly slower than the others. So this gives you some insight into what's going on.
Yeah, totally. And, you know, the key there, right? Like the bigger your container is, the number of partitions, the higher the latency is going to be if you've got to hit all these things. And you will clearly see that if you start writing out these diagnostics and seeing all the partitions you're touching within there. And so it should immediately be a red flag, like, oops, I got a bad query, or I need to think about how I'm partitioning my data so that I can get a better performance on my query. So yeah, this is cool.
Yeah, totally. So now that we've looked at a lot of metrics, we've printed out execution times and stuff, but we're printing it all to the console, which is not really that helpful in a real application. I mean, ideally, I'm not like scrolling through my console to figure out what's going on in my application. And that really brings us to the monitoring piece. And I've teased a lot about OpenTelemetry, so let's talk a little bit about that. What is OpenTelemetry? It's basically an open source, vendor agnostic set of instrumentation libraries, and it has the ability to send your data to multiple exporters. So I'm going to be showing you how to send it to Azure Monitor, Application Insights, but you can send this anywhere. And if you want to send to multiple exporters at one time, you can even configure that. There's a lot of customizations and configurations. We have published our semantic profile. So everything that I'm going to show you today, you can see published, like exactly what attributes to expect and look for and what they all mean. But we'll walk through all of the components for OpenTelemetry.
And by the way, everybody's using this now, right? So if you're doing observability across workloads and services, everybody's emitting to this now, correct? So if you want to build kind of that full cross-service
yes,
kind of one
definitely.
deal, this is the right way to doing it. So
yeah, so there's a big push across all of the Azure SDKs to standardize on OpenTelemetry. And so you'll see, regardless of what SDK you're using, like if it doesn't support it now, it's likely on the roadmap. And this is going to be a big push for consistency and standardization. So for my one console app, when we go look at what the application flow looks like, it's, oh, my app talking to Cosmos DB. But it might be more complicated, right? You might have an Azure function, you might have event hubs, you might have, many services in your application. So this is really critical to understanding that whole flow. Yeah. There's really 3 pillars of OpenTelemetry, and one of them is logging. So I'm going to show how to set up my log forwarder. I guess I should start here. So the resource builder, I'm just creating my service. So I've called it Cosmos DB service. This is sort of what I'm going to name. So when I wire up all my components, they all have my correct service name. So they can all be bucketed together. After I set that up, I'm going to set up logging. So I'm going to do a couple of things. I'm going to get the configuration, the logging section from my configuration. I'm not going to show you what my app settings looks like because it has all of my keys. But if I switch to our documentation really quickly, and we actually have this link, it's the SDK observability link. If you can pop the short link up on the screen.
Got it.
But you can see what your logging should look like. So if you subscribe to this logging source, Azure Cosmos Operation, Request Diagnostics, and there's various levels. There's information, warning, and error. That is how I'm getting my configuration for my logging. There's various ways that you can add your logging configuration. So any way that you like to set it up, but those are the values that you need. And then I'm going to add OpenTelemetry here. And I'm setting my resource builder, so attributing these logs to my service that I set up later. And I'm also adding my exporter. So I'm choosing to use the Azure Monitor log exporter, and I'm passing in my Application Insights connection string. But you can set up any exporter of your choice. So there's no, reliance on Azure Monitor for any of these features. I'm just choosing that as my exporter to show you what the experience looks like. And then I want to make sure that I actually start my log forwarder so that I can actually forward my logs to this location. So the logs in this case are actually the diagnostics. So we talked about how bulky that diagnostics is. We showed you all the query metrics. That diagnostics string, it can be painful to figure out when do I want to log it? Where do I log it? Where does it go? So this will automatically send your logs to the correct place. You don't need to add any custom code in your application itself to set this up, and you'll just be good to go. The next pillar for OpenTelemetry is called tracing. And this is sometimes referred to as distributed tracing. And you may see distributed traces throughout like multiple components of your whole application. I'm just going to add a couple sources for Cosmos DB. This is still in preview, so I have to add this Azure experimental activity source flag. Once we reach GA, this will no longer be required. And I'm creating my tracer provider. This is all provided through the OpenTelemetry SDKs, and I add my sources. There's 2 sources that I can add here. So one, Azure Cosmos Operation, is the operation level telemetry. So think when I'm creating an item, it's that create item async function call maps to an operation. And there may be multiple requests under that, but this is all at the operation level, and there will be attributes provided. The next source is the request level information. So this is actually the TCP network requests. So those are those direct mode calls. If I'm reaching out to multiple physical partitions, they'll all have a note here, like a trace entered here for your request. So you can see exactly what partition key range you're reaching out to. It gives you the replica information. So you know which of the 4 replicas am I talking to? Is there an issue with one of them? And this will really help you get more insights into your requests. Again, I'm going to set up my exporter, and then you'll also notice I'm adding my HTTP client instrumentation. So we have our application in direct mode, which uses TCP, but there are still some network requests that go through HTTP. All of those metadata calls to the gateway are through HTTP. So if I want to look at those too, I need to also set up HTTP instrumentation. It comes through differently. It's not part of our Cosmos source. So it's really important, if you care about those, to also wire that up. And then I can actually go into my Cosmos options and make sure that I tell my SDK that I want to use OpenTelemetry. So there's something called Cosmos Client Telemetry options. There's a few flags here that we'll go over. So as a preview feature, we have it set to false by default. So the disable distributed tracing, sort of a double negative. It's set to true, so it's turned off by default. But you'll need to set this to false, which enables distributed tracing for your application.
God, really?
Yeah, I know, it's sort of a nightmare. Well, it's because of the default value. We want it to be off.
I am not confused by that setting.
Yeah, I know. I'm sorry about that.
It's not your fault. Oh my God.
Yeah.
Okay.
And then we also have some threshold options. So if you remember, we had our log level and I set it to warning. What the warning does is it enables logs for high latency operations. And there's 2 types of operations that you can set different thresholds for. So we have our point operations. This is typically CRUD, anything interacting with one document. So a create, a read, anything for one document is point operation. I've set my threshold extremely low because I want diagnostics to show for every request, just for demonstration purposes. I think if you set it to 5 milliseconds, it will be extremely verbose, but it's up to you. And then the second configuration is non-point operation. So this would be query, anything dealing with multiple documents. So transactional batch, anything like that is considered a non-point operation. And the threshold should be a lot higher. Again, I set this extremely low. I think the default, if you don't set these, is 100 milliseconds and 500 milliseconds. But I just deflated that to make sure that we get every trace.
Is there anything else to set within those telemetry options there? Or is that pretty much it? The distributed trace, turning on distributed tracing, and then the threshold. Is that it?
Yeah, that's pretty much it. There are some other configurations that we're considering. Maybe like RU thresholds, things like that. Actually, if there's something that you guys would like to see, please let us know. We'd love feedback on this feature. Just in the .NET v3 SDK repo on GitHub. Feel free to leave an issue. Tell us what you want to see, like what threshold options would you like to see. We've kind of opted for simplicity for now, but we're definitely open to expanding this in the future.
What is so when you enable distributed tracing, I'm seriously gonna file a bug on these guys to call that distributed tracing equals true, to enable it rather than disable distributed tracing equals false. So I'm in crazy land. What's happening behind the scenes when you are enabling distributed tracing, I guess?
So that's what allows the SDK to actually emit the events to the specific source. So the SDK internally has these sources and it's wiring up events as part of that source, and it's sort of sending them to OpenTelemetry so that OpenTelemetry can listen to the source and pick it up. So when you have this disabled, it's not emitting those events and it's not like creating the event. So there is a little bit of overhead involved with distributed tracing. And there's things that you can do like sampling if you don't want, every single request to actually emit data into application insights. For really chatty applications, it's probably overkill and you probably should have some sampling. But yeah, if you disable this, then all of that is just not even happening.
And then I don't know if it's below or not, but I didn't see anything that directly, like you don't DI Cosmos into this I mean, it looks like
Yeah,
you're
we haven't gotten there
DIing this
yet.
into factory logger into the app level, but then is that basically because okay, now I see. This is
Yeah.
where you hook it in.
So
Okay,
the final piece. So this is my options, which I'm sending to my client options. And
got it.
that is what tells the SDK to actually turn it on.
Got
The
it.
rest of this up here is actually just plumbing. So
Yep.
this is actually setting up like OpenTelemetry itself. It's not directly related to the SDK. So if you were using like ASP.NET, there's something called the Azure Monitor OpenTelemetry distro, which is just one package that you have to add, and it has all of this OpenTelemetry configuration like under the covers for you, so you don't necessarily need to think about it every time. But I just wanted to show you in a console app like what all the components are if you were setting it up yourself. And maybe if you're using a lot of Azure SDKs, you could subscribe to like Azure.star or Azure Cosmos. I mean, there's only 2 Cosmos, so you wouldn't do .cosmos.star, but you can configure this in a lot of different ways.
Yep, got it. Yeah. I see at the top there, that looks boilerplate basically for hooking into the logging factory for
Yeah.
app level stuff. So that's just saying right to this instead. So everything basically emitting to logs in the app are going to go through that. And then I see this is the Cosmos specific bits for our SDK, and then you DI that into the options. So got it. Okay.
Yeah. Exactly.
So a little bit of code
Yeah.
here, but this looks pretty straightforward.
Yeah, but it's all configuration, right? Like I'm not going into my business logic, and I'm not like lining up, collect diagnostics, if status code, if latency, if whatever. Like it really does do a lot of the heavy lifting for you. There's a little
and
bit
it's
of
all, like you said, this is all in config. It just gets out of the way of your code. Just keep your app the same, basically. So customers that want to take advantage of this should be able to do it with very minimal kind of changes, I would think. So
yeah, totally. So I'm going to run this one more time. It will take a little bit for these particular traces and logs to end up in application insights. But while this is running, I had done a workload earlier. So I'm going to switch over to my application insights blade, and we can take a look at what this actually looks like. So in application insights, I'm in my application map. And you can see my Cosmos TV service. I've had a couple different runs of this over time. And there's a couple different things that I'm reaching out to. So we'll talk about all of them. First, let's take a look at HTTP. So remember, even though we're using direct mode, we do still have some HTTP calls. You can see we're calling out to our container. So this is when we were making that connection to that container. We are getting our addresses, which is the addresses of all those backend replicas. So this is all of the metadata, really the configuration of your SDK. This is the reason that we say to use a singleton, because all of this time is going to be duplicated time and time again for every client. So those are HTTP. The next little grouping is actually for the request level metric. So this is one of the things that will change as we move towards GA. Right now, each name is really just what the operation was, but there's nothing grouping them together, at least from the top level of like, what container was it? What database was it? So that type of thing will likely change over time, but you'll still be able to see all of the details for, these are your direct requests. So the TCP request to the backend. And the last grouping is actually the operation. So I'm going to investigate the performance for all of my operations. And if you remember, we did 3 things. We created our item, we read our item, and we queried our item. So those are the 3 that you see here. I'll just click into the create, and we'll be able to drill into one of these create requests, and we can see exactly what was happening in the application. So I'm going to collapse this for now. And if you look at this duration, you can see this entire create item async took about 1.7 seconds, but there's a lot of child calls under here that really illuminate what's going on in the SDK while this is happening. So our first call is an HTTP call, and it's getting that product. So remember, we didn't initialize the container at all. It was just metadata until we made our first item call. And that's why our first call is like creating connection to the container. And then we need to get the PK ranges. So if you remember, our query had all those PK ranges. This is really important for the SDK to know, especially in direct mode, like what resources is it talking to? There's another PK range call. We have our addresses. So again, this is like all the addresses for the replicas. This is really a lot of like what's going on internally, but it illuminates when you think direct mode, it can, you can forget like what's actually happening under the hood. And using OpenTelemetry and all these traces, you can see like exactly what was happening. And if you look at the create document itself, the create was pretty short compared to the overall time for the operation. And we also have a couple things here. So like if you did care about what replica it was, we have like the particular partition, replica, RNTBD is like our internal protocol built on top of TCP. So it's not really, it is advanced. You don't always need to know all this information, but we offer it here and you can see like the status code. So you can see, are all your failed requests coming from one replica or not? And it really gives you a good insight into the whole
And these
flow.
are good. You want status code. And of course, if you're getting like a 400 on there or something, you want to see sub-status codes as well, which I see a little box there as well. Because when you're talking to support folks, they're invariably going to ask, okay, I see you had a for something. What is your sub-status code? So having this thing wired up is immediately going to provide benefits if you got to dig into what's happening with particular operations or requests. So this is
definitely.
very cool. Yep.
And there's no custom logging. I didn't need to like ask to log these things. The list of properties that we expose here may change over time. As we move towards GA, it will eventually move to stable. But this is the things that we expose for now. And I also want to show some of the custom properties on the operation itself. So we see the database, the container, the container, the operation. There's a couple things that are interesting here. So this is machine ID. Say I had an AKS cluster and one of my nodes was constantly erroring, like all of the errors came from one machine. This can help you understand what's going on. So this is my hash machine name that represents like my unique machine that was making this request. And I also have the client ID here. So if I can look at like how many client IDs do I have per machine name, we'll look at a query to dig into that data in a little bit. But that really helps you identify like, are you using a singleton? Are you constantly creating new clients? What's going on there?
By the way, that machine ID, so is that translated from that user agent? I think Cosmos or .NET SDK allows you to send a user agent over, right? Within the connection?
Yeah, it does. So the user agent is a separate item. This is actually the hash machine name. So if you're running it on your local machine, it doesn't have like any PII or anything, but it just basically takes like the actual name of your machine and it hashes it, turns it into a GUID. So it's just a unique identifier for the machine. It's not necessarily related to the user agent. If you have a VM in Azure, like sometimes it will show the VM ID here, and it will have the ID of that VM. So it can represent in a slightly different ways, which is why it is prefixed here. So we tell you like, what does this GUID represent? And then what is the GUID?
Got it. So I could use that to suss out, like if I have a particular node that's misbehaving, that'll tell me where it's coming from, right?
Yeah, and depending on your environment, the VM ID may not be available. So we'll use machine name as a fallback.
Got it. Okay.
Yeah. All right. So before we dig into the logs, I wanted to show you one more thing, which is what the queries look like. Because there's one extra property on query, which is useful. So I see my end-to-end transaction details for the query. And again, this is just for one round trip. So they're not grouping all my round trips together, but I can see the underlying call to the database. So this is like getting the data for my query. And there's a lot of extra time here because we had that cross-partition order by, and it had to do a lot of work on the SDK to like get the data together, order it. So you can see like where the time is actually coming from in your request. And if I scroll down, so this is just one round trip, which correlates to this activity ID. But say I wanted to look at all of the round trips for my query, I can use the correlated activity ID. And I can query by my correlated activity ID to see like all of the round trips for that query. And then I can look and see like, was one round trip a problem? Was it at one partition? It just gives you better insight into debugging that specific thing. And we can take a look at what that looks like in logs. So I'll just open up the logs here. And I'm going to ignore the default query that it gives me. Just going to delete this default query. And I'm going to paste in a couple of my own queries. So let's say for that correlated activity ID, I want to find like all of the other round trips. Oh, that came back. Let's see. So here I'm going to look at all of my dependencies. I'm going to filter to whatever time period I want. The type, this corresponds to our RP name, which is Microsoft.DocumentDB. If you've been using Cosmos DB for a long time, you may know that DocumentDB is a legacy name, and our RP in Azure is still named that way. So that's our type. And we have our custom dimensions here. So I'm going to look at our custom dimensions. This is what we were just looking at, the correlated activity ID. I'm going to search for this particular one, and then I can see all of those round trips for that query in my results view. And this particular query had 3 round trips. I can scroll, I can look at all of the custom dimensions. So everything for that particular query, how many items were returned. Here we see the VM ID. So sometimes VM ID will populate. This is like the VM that I made this request from, and the region, and everything about like that particular request. So a few other queries that might be helpful. The actual query. No, we don't log the actual query because it's considered PII, and we don't have that information. But it is possible, like maybe we can think about exposing it in the future. I'd actually love to hear from, if anyone wants to see the query here, like please let us know what you want to see in these attributes, and we can definitely augment them.
I mean, you can turn that on. There's a PII flag, I think, for the log analytics piece of it that allows us to write that out.
It goes to the Cosmos diagnostics, not the SDK. So it would be different, and we need to figure out the right way to do that without, of course, like exposing any potential issues. So we didn't do it in this first pass. But if customers, if you guys really want to see it, please let us know, because we're always happy to revisit.
Yep. Okay.
Yeah.
This is great. A lot of information in there, which is really just awesome.
Yeah, it really helps you understand like the whole flow of what's going on.
Yeah.
And other things that we had talked about, I'm just going to paste a couple more queries. So we talked about the figuring out like how many clients you have per machine. So this could be like, are you using a singleton or not? So again, I'm going to filter to this type, which is DocumentDB. This time I'm going to look at the target that contains DB. So my database name was just called DB. So I want to see like for this database, how many client IDs do I have by my custom dimension of machine ID? So if I run this, I'll see that I actually, I'll see that I had 2 machines that I was running this from, and they each had 3 clients each. In this case, it is because I'm running my application 3 times, and it's just a client app, so I expect to have a different client ID each time. But for a real application where you really only expect to have one, or maybe one every so often, this can help you understand. You don't always have to do a count, of course. There's a lot of different, more complex queries that you can do with this data.
Is this your teaser for when you can find if you got multiple instances of the SDK running on a machine? Is this what you were talking about?
Yeah, exactly.
Okay.
Yeah.
Yeah, this is cool.
This is how you can do it, by looking at all these custom dependencies and logs.
Yep.
Yeah. And the last query that I want to highlight is looking at maybe potential errors that were coming from one machine or another machine. So I'm going to run this query, and oh, yeah. So I forgot. This query is looking at my database. It's looking for status code where it's not equal to 200 or not equal to 201. So it's looking for failed requests. And then I'm going to group them by machine ID. I don't actually have any failed requests, so that's why this is returning no data. But if you wanted to see like where all your errors coming from, I could even like put this on equals to see like how many successful requests were per machine. So there's a lot of different aggregations that you can do. I don't know why that's not returning results, but it's the and. But yeah, so I just wanted to show you like how you can look at the logs and how this can really help you debug your applications.
Now, can I take this and create alerts off it? Like I can.
Yeah, so that's. That's a good question. I'm sure that you can. This is just wired up through Log Analytics. So anything that you have through there, I'm sure you could. Yeah, that would be a great follow-up. I'll have to look into that.
Yeah, no. Just I didn't expect. I'm sorry to put you on the spot, but yeah, this reminds me like, hey, if I can get all this great telemetry, and like you're saying, I can run a query and I don't see any failed requests, but if I create a query and I start seeing failed requests, then boom, fire an alert and let everybody know. And if this is fire, and if you're saying this is going through log analytics, then absolutely right. You should be able to take this and then just generate alerts off this stuff. So
yeah, totally. Or
cool.
build like dashboards and stuff in Application
Yep.
Insights. There's a lot
Yep.
of things.
Yep.
Yeah. One thing I realized I didn't show, so I'll just quickly show, we talked about getting the diagnostics. So if you go to your traces, there's traces associated with the request, and this just has the diagnostic string. So I can see like its latency was over my threshold, and that's why I have my query metrics here. If I didn't want to expose them directly, and I can look for other things like CPU. High CPU is a really common cause of issues on our SDK. Anything up to like 40% is good. Once you start getting to the 70+ range, you might start seeing timeouts and other errors. So yeah, there's a lot of information in the diagnostics. We don't expect you to use like every single bit of it, but just understanding where it comes from and how you can wire up diagnostics so that you can capture them really easily, automatically, without a lot of custom code.
Yeah, and we do document this stuff too, by the way. This is in our troubleshooting section, I think, for our docs that say, hey, if you're seeing these things, these are some of the things you should look for, in things like thread starvation and high CPU utilization and all that stuff.
Yeah,
is all stuff you can find by just kind of twiddling around in our diagnostic strings and seeing what's going on inside there. So
yeah. So that's all that I have today. Maybe I can leave the audience with a link to our .NET best practices. A lot of what we covered today is all in our best practices. You can get to our troubleshooting guides from there as well, as Mark just mentioned. There's really a lot here, and I'm really excited to show it to you. Please keep a lookout for GA. We'll be adding metrics, which is the third pillar of OpenTelemetry that we did not talk about today, not available in .NET, but a lot of new stuff coming out. And yeah, I hope you guys enjoy. Please give us feedback on GitHub.
Yeah, absolutely. And this is great. You know, you're building a live service. You need a way to be able to do this monitoring and this observability. And of course, you need to be able to troubleshoot and find when issues are happening when you have a live site or you're trying to debug through live issues. So knowing these best practices is super important. I'm going to throw up this other link on the OpenTelemetry stuff that we've now got. And also, this is super important. And, you know, this is great. All of the Azure SDKs have now are all, focusing around this single OpenTelemetry API for doing all of their logging and I don't know what you call it, observability, I guess. I don't know.
Yeah, observability. Yeah.
Observability is what we call it everywhere. I had this other one as well, this link for the getting started. You want to tell me, is this, what's this one for?
Yeah, so this will point you to a quick start. If you haven't used the .NET SDK today or yet, you can go to the Getting Started guide, and it'll walk you through a sample application and really help you acquaint yourself with the SDK.
All right. Very cool. Well, hey, Justine, it's great seeing you. And welcome back to Cosmos DB TV again, even though we've got a brand new set for me, which is just a big plain brown box that I sit in.
Yeah, we missed the screen with the rotating Cosmos logo.
I missed all that too. It's all this, everything is sitting in a box somewhere. I'm not quite sure, but hopefully this will all get sorted out. Otherwise, hey, it's still the same fun show. I'm just sitting in a gray box. But that's okay. It's not about me. It's about you guys and all the cool stuff you do. So thanks for joining us, everyone, and thanks, Justine, for coming. Hey, folks, thanks for spending the last hour with us, and we look forward to seeing you on the next show. So thanks again, Justine, and thank you, everyone.
Yeah, thank you. Bye.
All right, bye.